Greetings, peeps! I'm Morad, your instructor for this year. Let's start by figuring out what is physics. What is physics? This is your introduction here. So it's really a study of several things, mostly space, time, matter, and energy. That's it. Those are the things that we find in nature, and we want to study their interactions, and we want to be able to do great things with it. So first thing we do is make some formal observations of physical properties. Physical properties might be things like mass. How much mass does an object have? How is an object moving? What characterizes that? So there are many, many questions we can ask when we start looking around and making observations of the physical world. But it's not just observations. We want to be able to characterize those observations. And we do that in a way in which humans can understand and in which we can communicate. All right? So those ways are depicted here. Mathematics is actually kind of a human endeavor in which we take these relationships, sometimes they are numerical, and we apply this to the physical world so that we can better understand how it works. So mathematics is really, really key to the study of physics. But also language. We're going to default by using English. I've invented my own language called Gibereka, but it's not really ready for public. Just think about it for a moment. Yeah, you're not going to understand that. So we're going to default to English. That's totally cool. And we can also use things like drawings and animation. Animation being really drawings over the course of time to see how they evolve, to communicate these findings as well in our observations. From that, we have these essential physical laws that are developed. They help us characterize and predict these situations, what the outcomes might be when two things interact. So in that case, we might have something like a collision, or we might notice that an object that's falling has certain behaviors that we can track and that we can predict. All right. So previously, I alluded to some questions that we can ask that physics may be able to help answer. Okay, so by making formal observations, and with observations, what I really mean is measurement. Taking measurement that can be quantified in a way that can be reproducible, and we can use those numbers to then make some terrific predictions about the behavior of physical systems. Here are some basic sample questions, but there's so many more. How do objects move? So we're going to study and characterize the movement of objects and see how they're influenced to exhibit particular patterns. What patterns of motion are found in nature? So that's exactly what we'll be able to explore. What happens when objects collide? So I alluded to that last time as well. We may look at some dynamics of things like an automobile collision, or what happens when there are many types of collisions. When you've got, for example, two billiard balls, what occurs in that case is something that we can absolutely explore with physics. What is energy? Geez, what is energy? We can be able to figure out what energy is. How many different types of energy are there, and how are they useful to us as humans? How can we take one form of energy and make it into another form of energy that we can perceive and oftentimes enjoy or find usefulness in the human condition, right? How do engineers apply the laws of physics to design and build different devices and systems that will enrich the lives of humans? So that's kind of it. The physics is a great endeavor by itself to learn about the world. Engineers take those principles of physics and make the world better for humans to live. The fundamental quantities of nature. There are four, just four, that's it. Physicists think about nature in terms of these four quantities. They are length, time, mass, and charge. And that's it. We can combine them in different ways to give us more compound and more interesting descriptions of nature. For example, area is the combination of length and times length, right? Area is length times length. If we wanted to go to volume, it would be length times length times length, or cubed, right? All right. Velocity, for example, or speed, is a combination of length and time. It's length divided by time. And something like force involves actually 3 of these quantities together, and I'll show you what that is later. It's a little more complex. Now, for each quantity that we have, there are relationships, mathematical relationships known as, well, equations that can help us determine what kind of or what amount of quantity we get if there are certain things that happen. There are symbols that represent each quantity. Symbols like L for length, hey. T for time, right on. M for mass, Q for charge. Maybe Q in another language is actually C or something weird like that. I don't know, maybe my other language. No, it's Q, that's just how it is, okay? Latin, okay? Area, we discussed this before, L squared. Velocity, L divided by T. Force, mass times length divided by time squared. So it's a big compound unit over here that, or compound symbol for representing force that represents this quantity. It's these 3 things combined together in a more complex way. We have a system of measurement as well. They're called units. We're going to adhere pretty strictly, almost always, to the MKS system, meters, kilograms, and seconds, for each of these quantities. So we've got little m that represents a meter, about yay big, about as wide as this board or so. But of course you might be seeing it on a tiny screen, so what does that mean? We'll get into actual scale in real life too, because I'm just a little picture in front of you, and how big is that really? Remind me to tell you the story about Picasso one day. Pablo. S for second, kilograms, kg for kilograms. Charge, well, we're kind of back to it. It's actually symbolized by the letter C, and it stands for Coulomb, named after Charles Coulomb, who explored the relationships between electrical quantities. M squared, meters squared. M divided by S, meters per second. There are other units that are probably more common in your everyday lives, like miles per hour, or MIPS, I like to call them. We're gonna stick to meters per second for most of the convention. In reality, it doesn't matter which system you use, but there are advantages to MKS because it's metric, powers of 10, it's just easy to use, and so we're gonna stick with it rather than confuse the situation. We will stick with that one system for you guys. And N for newtons. Newtons are kilograms, meters per second squared. It's a combination of mass and length and time, something called acceleration. And this is the measurement, the MKS, or System International Measurement of Force. Okay, so these are basic ways that physicists combine these physical quantities together to better describe the world, and so shall we in this exploration for the next year. Right on, hang with me, Morad out.